For 2.5 million years, the Earth's climate has fluctuated, cycling from ice ages to warmer periods. But in the last century, the planet's temperature has risen unusually fast, about 1.2 to 1.4 degrees Fahrenheit. Scientists believe it's human activity that's driving the temperatures up, a process known as global warming.
Our story starts in 1896 in Sweden with this guy, Svante Arrhenius, a chemist. Arrhenius is the first person to figure out that putting CO2 into the atmosphere could make the Earth warmer.
Ever since the Industrial Revolution began, factories, power plants, and eventually cars have burned fossil fuels such as oil and coal, releasing huge amounts of carbon dioxide and other gases into the atmosphere. These greenhouse gases trap heat near the Earth through a naturally occurring process called the greenhouse effect. The greenhouse effect begins with the sun and the energy it radiates to the Earth. The Earth and the atmosphere absorb some of this energy, while the rest is radiated back into space. Naturally occurring gases in the atmosphere trap some of this energy and reflect it back, warming the Earth. Scientists now believe that the greenhouse effect is being intensified by the extra greenhouse gases that humans have released.
Gases in the atmosphere, such as water vapor, carbon dioxide, methane, nitrous oxide, and chlorofluorocarbons, let the sun's light in, but keep some of the heat from escaping, like the glass walls of a greenhouse. The more greenhouse gases in the atmosphere, the more heat gets trapped, strengthening the greenhouse effect and increasing the Earth's temperature. Human activities, like the burning of fossil fuels, have increased the amount of CO2 in the atmosphere by more than a third since the Industrial Revolution.
A single flight from New York to San Francisco or Europe creates 2 to 3 tons of greenhouse-causing gases.
Burning garbage actually looks less favorable than coal or natural gas in terms of CO2 production.
Coal is incredibly important. It's cheap, one of the cheapest sources of energy available, and it's one of the most abundant energy sources in the world, even more so than oil. But it does have one huge drawback. It's so dirty that people regularly die from its pollution. When coal is burned, it releases chemicals like sulfur dioxide, nitrogen oxides, a little mercury, and carbon dioxide, not to mention a bunch of various particulates. These leak into the air and water and result in smog, soot, acid rain, global warming, and toxic air emission.
Deforestation impacts the amount of greenhouse gases in the atmosphere in 2 ways. First, when trees are felled, they release the carbon they are storing into the atmosphere. Second, trees play a critical role in absorbing the greenhouse gases that fuel global warming. Fewer forests mean larger amounts of greenhouse gases entering the atmosphere, and increased speed and severity of global warming.
The more dependent we are on meat, milk, and eggs, the greater the CO2 and methane emissions. Cattle produce methane as a byproduct of breaking down grass and other things that they feed on. Methane is something like 22 times more potent as a climate-changing gas than is CO2, so it doesn't take very much methane to make a difference.
One cow's not a problem, but now we have 1.5 billion of them. And it's an incredibly inefficient way of producing food. 3/4 of agricultural land is used just to feed livestock. When you factor in everything, the clearing of the land for grazing, feeding, transporting, livestock causes more greenhouse gases than all the direct emissions from the entire transportation sector.
Let's take nitrogen, the nutrient most commonly used in food production. This vital nutrient is required to produce healthy food and replenish soils. However, its application needs to be properly managed to prevent the production of greenhouse gases. But in waterlogged soil, there is very little oxygen available for bacteria that live in soil. Under these conditions, some of these bacteria adapt by using nitrate rather than oxygen to respire. As this occurs, they release a variety of gases, a process called denitrification. Most of the gas released through denitrification is in the form of N2, which is naturally occurring and makes up almost 80% of the air we breathe. But a small amount is in the form of nitrous oxide, N2O, a greenhouse gas. 300 times more powerful than the most common greenhouse gas, carbon dioxide, CO2.
The rapid increase in greenhouse gases in the atmosphere has warmed the planet at an alarming rate. While Earth's climate has fluctuated in the past, atmospheric carbon dioxide hasn't reached today's levels in hundreds of thousands of years.
If you are a millennial, you've probably spent your whole life hearing about the hole in the ozone layer. Before you can understand the hole, though, you gotta know what the ozone layer is. The ozone layer isn't really its own thing. Instead, 90% of our ozone floats around in the stratosphere, about 6 to 30 miles above our heads. Ozone is 3 oxygen atoms linked together, O3. When in the stratosphere, ozone absorbs harmful UVB radiation, protecting us and other life here on the ground in the troposphere. In the late 19th and early 20th centuries, people were just beginning to harness the power of refrigeration. In 1928, an enterprising inventor at General Motors created a non-toxic chemical for refrigeration called CFC, chlorofluorocarbon. It was patented as Freon by DuPont and sold in air conditioners, fridges, bug sprays, spray paints, hair conditioners, and healthcare products. At its peak, companies were making 1 million metric tons of CFCs every year. Sure, at sea level, CFCs are non-toxic and safe for humans, but if they get into the upper atmosphere, they're subject to photodissociation, where UV radiation breaks a chlorine atom off the CFC. If that free chlorine finds a molecule of ozone, O3, it will react with it, destroying the ozone by ripping off one of its oxygen atoms to make chlorine monoxide, leaving regular old O2 or oxygen in its wake.